There we go. Here's a graph of the function. Okay. So a local max and min, or relative max and min, is high and low points, but not necessarily the highest point, because this keeps going up. So it's not the highest point, but it is a high point in a certain interval. And so that's what they're calling the max. And this one wanted the min. So this is a low value. It's a local min or relative min because it's not the lowest point. If this line didn't keep going down, this would be an absolute min. But right now it's only a min. A local min value of h at, and then all the values at which 8 has that min. The first one, h, is your function. So it wants the y value. All local minimum values would be -4. All the values at which 8 has a min, that would be, there's only 1, and it's at 1. So this wants the x value. This is the y. I think the wording's a little strange, but this is the minimum value when x is 1. Let's try another one. This one we're finding a max. We'll do both, but the first part, it's asking for the max. The high point in the graph is here. These keep going, so we wouldn't use the endpoints, but this is a local max. So there's a local maximum value of g is at -1. Because the function is g, that means it's the y value. All the values at which g has a local maximum. 1 is the x value. If we look at the local min, notice there's 2 low sections depending on where we're looking. So there would be 2 minimums. There's a local min of, if we look at this first one, -3 at x equals, and the x value is -2. There's another local min of -5 when x equals 4. So they want the y value that's at a high or a low point, depending on which one they're asking for, and x value that gets you it. Any questions on those? The increase, I guess we could, this is a good one to do the next part above it, which is increasing and decreasing. When you're increasing and decreasing, you're going along the x-axis. And notice the graph is always start on the left. It's coming down until I hit -2. So it's decreasing from -infinity to -2. Then it increases in this section here, which is from -2 to 1. It increases. These will all be parentheses because it's continuous intervals. From 1 until 4, the function decreases. So 1 to 4, it decreases. And after 4, from 4 to infinity, it keeps going up. So it increases from 4 to infinity. Depends on what they ask. Usually you should use a U for union. Sometimes they just say a space or a comma. Is there any questions on that? Do you need to see another one of min and max increasing, decreasing?
No, I think I understand it.
Yeah, it's not too bad once you see it. Let's do one that has everything. And if our points are 3, 4, 0, 0, and -3, 4, -4. So if we had these points and this was shifting this 2 is on the outside times the y value, because remember f of x is y. So we multiply the y's times 2. This 3 is on the inside, so instead of multiplying by 3, multiply by its reciprocal. Because when it's inside with the x, do the opposite. So since it's times 3, multiply by its reciprocal, 1/3. So do your multiplications together, and then we'll do the addition and subtractions together. This one's on the outside for the y, so we multiplied the y's by 2. This is on the inside with the x, so we multiplied by the reciprocal. 3 times 1/3 is 1. 4 times 2 is 8. Zeros will stay 0. -3 times 1/3 is a -1, and -4 times 2 is -8. So these stretch and compress the graph. This -1 moves it right 1, the 4 moves it up 4. So right 1 means we need to add 1 to our x values so that it moves over 1 on the x-axis. Up 4 means the y value needs to move up 4. So then we have 2, 12, 1, 4, and 0, -4. Any questions on that? Oh, sorry. Did anyone else get cut out? Okay. Someone just got cut out. But my one class Wednesday kept freezing. I don't know what was going on. So outside multiply, or whatever this says, do what it says. Inside, do the opposites. Any questions on that? Okay. Do you need to do one more? Yes? No?
Sure.
Maybe? Sure. Okay. One from, yeah, we might as well do one from here that way. Those are the same ones, aren't they? Okay, this is definitely different. Yes, it will. It's all recorded. Dan, this one will definitely help a lot, so make sure you watch the video. Okay. Y equals 2f x minus 4. So this 2 is on the outside. Oh, let's write the points first. So we have negative 4, 0. Negative 2, negative 4, and 0. This 2 is on the outside times the function, which is y. So we're going to multiply the y values by 2. There's nothing inside with the x to be multiplied, so we don't have to multiply. Negative 4, 0, negative 2, negative 8, and 0, 0. Multiplying by 2 times 0 is still 0. The minus 4 is in with the x, so it's the opposite of the sign. It's going to move right 4. You think about the x-axis, when we move right 4, we're adding 4 to the x value. So we get 0, 0, 2, negative 8, and 4, 0. And then you would have it plot those points and it will graph it for you. Any questions on that one? I think I'll have enough room. So if we write our points, negative 2, negative 4, 0, 0, 4, negative 2. Negative is going to flip on the y-axis. So it changes the signs of the x values. When it's outside, it changes the y's. When it's inside, it changes the x's. So we multiply these by a negative 1. So we have 2, negative 4, 0, 0, and negative 4, negative 2. The minus 3 moves down 3. That's your y. So it's going to move your y value down 3. You take 3 away from each of your y values. Any questions on that? So you kind of remember, this will definitely help you remember your shifting rules. You'll probably never see it written like this again. Any questions on it? Okay. Any other ones? Value. I don't know. What do you have? Is there anything else you're stuck on? Oh, we got 20 minutes. I couldn't hear.
Really.
Can't really
Oh no, most of my stuff is usually
in the next
no
group.
if I have a problem. Yeah.
Write an equation of a function after a vertical and horizontal transform. Wait, let me see what these mean. Remaining. Okay, this one, well, this shows 80 people are ready for this one. Yes. You could have just looked at the graph and did that. Which ones were those? Here it is. The only thing you need to be careful on the flipping ones is if we're multiplying. Oh, this isn't it. If we're multiplying. Like if you have a graph, if they're just shifting like that last one was, I'm just going to draw a graph. This negative makes it flip. So if this is at 4, this will be at -4. So we know it goes here. And then this is our new graph. If this is at 2, this is at -2. And then the -3 makes it go down 1, 2, 3. Move each point down 1, 2. I guess I didn't put what this was. We'll make it 3.
Oh, can't see.
Oh my, I'm sorry. So if we have the -x, it flips it on the y. And then you have to move down 3. What you need to be careful of is when they put the numbers in here, the 2 here or here, then you have to do more stretching, and have those points written helps. But when it's just flipping or moving up, down, right, and left, you really don't have to write the points. I only recommend them for ones where they have the multiplication in front, like this one did. That's the only case I would do, is when there's a number multiplied here or here. Shifting wise, I would just visually flip it. So when it's inside here, it's here. If it were outside, it would flip it here. And I always flip before I move. Sometimes if you move first, then when you flip, they tend to flip at that axis rather than the whole x-axis. They'll flip at a point. So flip first and then move. Any questions on that? So this one was a -x inside. If the negative's outside, it flips this way. Any other questions? Writing the equation for function. I think that was easy. I think the only other one that gives problems is the transforming graph. Where'd it go? It was the one where you find the symmetry for a function. I don't know where it went. Oh, here. If we had a function and we wanted to check its symmetry, is everyone okay with those ones?
Yeah, where like you make the x negative and the y negative, and then yeah.
Okay, because I had gotten a lot of texts on them. But does anyone need to see those? You'll definitely see one of those on an exam. Any other ones? It shows that those ones we just did, there's 91% of the people are ready for those. Piecewise functions, which we did a lot yesterday. Do you need to see more piecewise?
No, when we did them on Wednesday, they were really helpful and it made a lot of sense.
Too. Oh, one person needs one. Here, we'll do one. And make sure you watch the video on these. I mean, you don't have to watch my video. Watch this. There was 2 different people. They explained how to do it on Alex. So once you know how to do the graph, they'll show you how to erase on Alex. This is a good one. I like this one because it shows all 3 parts. You'll definitely see something like this on the exam. Suppose that the function f is defined on the real numbers. Now, 6, y equals 6 is a horizontal line going through the y-axis at 6. So it would be this line. And Alex will have you draw it. But if we look where -4 is, 3, 4, -4, this says x has to be less than -4. Well, less than -4 is from here over. So we got up to our point. We're not including it because it doesn't have an equal to. It just says x less than -4. Then it wants everything this way. So then on Alex, you will mark that one point and erase the rest. And you go to the next one. That's a parabola. I know it's a parabola because it's x squared. It's positive, so the parabola going upward. The -10 moves it down 10. 5, 6, 7, 8, 9, 10. And it's going upward. But I don't know where it's going to cross. I know that my endpoints, if we look at this interval, are from -4 to 4. So I want to keep the parabola in between here. We'll then plug those values in and see where the point is. So if I look at -10 plus x squared, and I plug in my values, -10 plus a -4 squared, 16 is 6. Plug in 4. -10 plus 4 squared, 16 minus 10 is 6. So I know that this is going to go up to -4, 6. And that was equal to, so we color it in, because this has equal to right here. This one does not, so the 4 will have an open circle. 4, 6. So my parabola goes all the way up to there. It's an open circle because it didn't have an equal to with it. So it would first graph that whole parabola, then you would mark these 2 points and then erase it. This over a little bit more. The last one is for x greater than or equal to 4. We know this is a straight line. We know the y-intercept's -2 and the slope is 2. So if we move down 2, and we go, slope is 2, up 2 over 1, 2 over 1, 2 over 1. It's this graph. But we only want to go greater than or equal to 4. If we plug in 4, 2 times 4 minus 2, 8 minus 2 is 6. So the point is 4, 6. And it's including it because this has an equal to with it, greater than or equal to. And then we want everything greater than, so we only want this side. And then we would erase this side. So you're graphing 3 separate graphs and only keeping the part that covers these points for x. But it's an important one because then we check limits of infinity and at certain values. Then it asks you if it's continuous. This one, I could trace the whole thing lifting a pencil. This is continuous. If this would have left an open circle and maybe been up higher, where there's a break in the graph, then it's not continuous. But this one is continuous. I know, yeah, these ones do ask that. Any questions on that? Okay. Any other ones? I'm trying to think. I think we covered every one. We got about 8 minutes, so at least one more. I think somebody texted me this morning about this problem. Maybe not. Is there any that anyone needs to see? No?
Actually, graphing a wait, hold on, I have here. Graphing a piecewise defined function, problem type 3.
That's what we just.
Oh, you did. Okay, I'm sorry.
Yeah, that's the one we just did. Okay. On a test, there will be kind of like, you know, I did the solving the equations. There was like 8 of them together. The last problem on the test. I would do something like that with these graphs, and you'll have each graph. So, like, what does the square root graph look like?
It's
I know.
Oh my god, how do you describe? It's sort of, it's just going one way. It's
Yep,
like
it's a half of a parabola, or it kind of looks like the square root. So this would be the regular square root. That negative, how does the negative on the outside flip it?
Wouldn't it? Ooh, it would flip it over the x-axis, right?
Correct. When it's outside, it flips it over the x-axis. So it would be down here. So there would be a bunch of graphs, the cubic, the squared, and you should be able to do them quickly because they're either flipping or shifting, maybe both. So another one, y equals x plus 1 squared minus 2. So what's the graph look like? It's squared.
It's gonna be a parabola, but just down 2 from the order.
Yep. So it's a parabola. It's going up because this is positive in front. So this is our basic graph. How does the 1 move it?
You're gonna move it since it's a plus. You're gonna move it the opposite. It's gonna be left 1.
And the negative 2, I think you already said down 2.
Yeah, down 2.
So this graph moves left 1, down 2. And I'll probably ask a question like, is this a function? And it would be. Or maybe domain and range, things like that. But it is a function because it passes the vertical line test. About this one. So what's the cubic graph look like?
A snake. That's the only way I can describe it.
That's exactly it. And this negative flips it, just like this flipped on the x. It flips it down. So instead of the snake increasing, it will be decreasing. And then that plus 1 is going to move it how?
It's gonna move it up 1.
When you're trying to draw the snake, although that one wasn't very good, think of it as a parabola, and then this part is flipping down. It'll help. Square root cubic. Absolute value. Okay, let's do that. So what does the absolute value graph look like?
A V.
And this one is going to be going upward because outside of the absolute value is positive. So the basic graph is this. How does the negative 2 move it?
Down 2. Wait, no. Right 2.
Correct. It's inside with the x opposite of the sign. Right 2. Any questions on those? Okay, let's try one more. Does anyone remember the cubed root?
No.
This is a new one. They've never had this in Alex before. They added this one. What it is if you think about your snake, your x cubed, it's on its side. So it's going like this. Whoops. So it looks like this. And then the minus 1, how does the minus 1 move it?
Right 1.
And the 3? Up. So we're going to move right 1 and up 1, 2, 3. So this point here, which is called the point of inflection, moves up 1 and 1, 2, 3 here. And then you have your graph. So all of these graphs will use the same shifting. And there'll be one on your test and it'll have all the graphs that we covered, just shifting them. And then the next group of modules gets into the fractional ones, like 1 over x and 1 over x squared, which we have a little bit in here of knowing what the graph looks like, where it went here and here. But the squared one makes this negative positive and flips it up here. And so those would be into your test also. Is there any questions on shifting? These problems are on there also. These are in this module, and it shows you the graph, and then it just asks you how it should move it, or it has you move it. But these are in there. Okay. Then have a wonderful weekend.
Have a good day.
Thanks, you too. Okay, if you don't have any questions, I will see you on Monday.